Okay, guys, we're here with the Polaris guy that helped develop and build this new clutch for you. He's about to tell you a little bit about it.
Right, so we can start by talking about airflow. There's two different things. There's airflow and there's heat transfer. We don't necessarily care about airflow. What we care about is heat transfer. So our model years 16 through 18 XP turbos was an older style clutch box that inlet at the center here. That clutch box would flow about 250 CFM at full speed. So we, as an improvement on that, we went to a new style clutch box for the Turbo S, and that flowed about double the airflow, getting up to about 250 CFM, or 500 CFM I should say, with that, which was a pretty good improvement, but we can still go further than that. So with this new clutch box, what we did is started from the ground up with analysis for heat transfer through the system. So what we do, we don't actually flow more air than we do with Turbo S, but we make the air do much more work before it leaves the box. So the air comes in at the center of the driven clutch. The driven clutch in a Razor in higher speed applications is the fastest moving clutch in the system. We make that clutch work as a centrifugal pump by bringing the air into the center. The fins catch it and move it radially outward. We use all the pumping power of this clutch to then force the air through this channel on the backside of the clutch cover down behind the drive clutch. This is one of the hottest spots in the clutch box, and also one of the spots where it's difficult to get air down into the center of it. So we force the air down in there. On the backside of the drive clutch, we have a redesigned fin geometry. This is driven by a lot of analysis, optimizing fin height and surface area for optimal pumping, but also optimal heat transfer. So we also use this clutch again as a pump on the backside of the drive clutch to then force the air through another channel to the backside of the driven clutch again before exiting. So we make the air hit all four sheaves before it exits the box. This isn't just warm air coming out, this is hot air. We're focused on getting the heat out of the clutch box. If you think about it, a really efficient CVT system may be 90% efficient. A really efficient gear-on-gear transmission might be like 95% efficient. If you have 180 horsepower and you're 90% efficient, that means you have 10% loss to heat and friction, which friction ends up being heat. So for 180 horsepower, that's 18 horsepower of heat that you have to dissipate in this system operating efficiently. So heat is what we're going after to try and remove. That's how we improve our belt durability in high speed, high load situations. So this is designed with heat transfer in mind from the beginning.
So this is the first design in actually addressing the back half of the belt heating up.
Yeah, right. Addressing specifically, lots of analysis. We've put a ton of R&D resources into getting at this problem from the root and starting over and kind of changing our methodology. Lots of CFD modeling, lots of heat transfer modeling, lots of dyno testing with temperature sensors all over the clutch box. Lots of hours spent personally out in the desert, blowing belts, finding the limits, changing things, rapid prototyping parts. We've thrown a lot at this. We still are working on more things every day. I mean, we're working hard on this issue, but what we have here is a significant improvement over what we have on the market today.
Yeah.
I think customers should really see some improvements with this.
And not to be underscored by no more dropping bolts in the sand.
Yeah, right. Well, when I spoke about us doing a lot of testing on our own, all of our engineers are very involved. We're out in the shop, we're out testing, we ride, we wrench, we fit parts together in addition to doing our design work at our desk. So there might be a week where I take a clutch cover off 50, 60, 70 times, and we think about like, what are the pain points that we have and how can we integrate this into the, I mean, when it's 110 degrees outside and you blow a belt in a desert wash, you don't want to be dropping bolts and doing stuff like that. The bolts are hot to the touch. You don't want to put them in your pocket.
Well, you know, it's funny because for 10 years I've been carrying a sheet in the back, and I would throw the sheet under the car before I started taking bolts out.
Just so you don't lose
Just
stuff.
so I didn't lose them.
Yeah, right.
No
so
more.
You don't have an issue with these anymore. You can take this, throw it over your shoulder,
Sure.
whatever.
Yeah.
These things are replaceable. You can snap them out if you get a screwdriver or pliers on them and put a new one in. Say you should damage the threads on one or something like that. So it's not like you need a whole new cover if something happens with that. Another thing that has been a pain point in the past with the turbos, we have a cast aluminum clutch cover with a tongue-in groove design where there's a groove on the back of the clutch cover. When you take those covers off, especially when they're hot, they can kind of warp a little bit. And then to get them back on, you got to kind of move them around just right, get them to snap in. this cover, the sealing surface is flat on the back, and the seal is held in this groove here. So
no more fighting with the gasket.
you don't have to fight with the gasket. The gasket does a pretty darn good job of staying in here, and it's also on the part that stays stationary versus the part that you're trying to weasel around.
Sure.
So you don't drop it. But with the flat surface, there's a lot less concern about it fitting just right because it's flat everywhere.
Yeah.
We have these guide pins here that fit to tapered holes in the cover to kind of guide everything into place. These bolts have kind of a bullet nose end on them, so they find their home and find their threads. They line up pretty well.
Cool.
So we have a lot less tolerance getting everything just perfect. And then the last thing is on this vehicle, the Pro XP, there's a good amount of clearance between the shock and the clutch, so that it's not such a struggle to fit the clutch cover down along there. I know some of our past models, you gotta hold your tongue just right, get everything just right to squeeze it in there. There's a trick to it. This was a lot simpler.
Yeah. And what can you tell us about the primary that's changed? I noticed the sliders are gone.
Yeah, pretty much everything. So overall, just a simpler design, a bigger design, and overall designed for less wear, more tolerant of dirt and sand. So in the past, those of us who've been around Razor for a while, this clutch was released in 2016, and there were some bad tower wearing issues. So then these stainless steel shims were added to improve that. But with the sliders fitting over the end of the spiders, you have two sets of wear surfaces. You have this tower wear surface, but you also have the slider wearing on the spider. So you may have cases where you have worn out or broken sliders and you want to just replace the sliders, but the spider is also worn, so you have to replace the spider. Gotten away from that completely. With this new design, it's really, in design concept, it's an old design. It's a button style clutch, but we have rubber back buttons as we've had in the past, and they're much larger than they used to be. A lot larger contact pressure, so all of your load is spread out over a larger area, and the rubber backing allows the button to conform and maintain the largest contact pressure through all different sorts of situations. This material is a graphite infused Vespel, designed to run on aluminum and be the sacrificial material, but also have good wear properties. So we're trying to avoid having wear on the hard parts, the expensive parts. Every part in this clutch is going to be serviceable, so you can buy the individual piece parts. If your buttons wear out, you can just replace the buttons. You don't need to buy a whole new clutch or anything like that. Same goes for rollers, roller pins, bushings. The shift weight has a bushing in it now, as opposed to on the turbos before it was just metal on metal, which had some wear issues, had some inconsistencies, especially if they sat outside, got a little condensation rust in them, a little jerky on takeaway. This is far more consistent, far more smooth, better over the life of the vehicle. And we talk about upsizing components, there's the strength aspect of that, but it's also for wear. If you look at the size of this roller is almost an inch wide, has a 10 millimeter internal diameter as opposed to this one that's much smaller. All the load that this roller sees is spread over a much larger bearing area, which transmits to longer life, more consistent performance. And the shift weight also is wider to again distribute the load over the roller better. So overall, going after consistent performance, when you have all these wear surfaces over time, they get sticky, they get dirty, they start to wear. Your clutching changes over time, particularly with the driven clutch. And with you, we've gone to a roller design. This is very similar to our Ranger XP1000 roller design. That's what started with this. We have a heat-treated helix. Should last the life of the vehicle. Very strong, very durable. We have rollers. It's a 3-roller design on the driven clutch that runs on those helix ramps. The rollers are easily replaceable. They're a Torlon roller, just a simple E-clip to take them off and put a new one on if they wear. We've had very good wear capacity with them. Haven't seen much in the way of flat spotting like we've had on some of our past designs, past driven clutches.
And we also have the ability to add shims for clutch alignment.
Right, that's right. So I'm with the XP Turbo and Turbo S we have now, everything just bolts together. There aren't any provisions for adjusting. So I've had people talk to me that they've had clutch alignment issues where they've loosened motor mounts and tried to move things around and shift things a little bit. With this system, you can, if you have that issue, you can simply take the clutch bolt out, put a shim or add a shim, take a shim out, whatever, move it around to where it needs to go, and you can do that process in a few minutes as opposed to trying to shift things around and hoping for the best. Another thing with this clutch, talking about alignment, that taper joint between the clutch and the crankshaft is a pretty sensitive joint. If people don't clean those properly, if there's oil on them or if they're dirty, for a give, or if the bolt isn't torqued properly, the clutch will seat in a different spot, and that can cause some of that alignment variation. With this system, for serviceability, you can service the entire clutch without having to take it off the crankshaft. If you take the clutch bolt out, you can actually grab this part of the clutch, pull it off completely as one assembly. It slides on the spider splines, and you get this complete assembly with the spring, the spider, the shift weights, the rollers, everything. You can take that to your bench, work on it, do whatever. You can slide the bearing off, replace that. The only time you need to take this clutch off the crankshaft is if you need to replace the sheave, if there are issues with that. So for like we've talked, we work a lot with our racers, and one thing that can be convenient for them, if you need to change a calibration or something in the race, you can have a few of these halves ready to go. You can, or if something's worn or something's damaged, you can pop this off, put a new one on, put the cover back on, and be ready to go in a very short amount of time.
Angle cut of the helix, is that about the same as the S?
It's quite a bit different. Part of that is due to it being a different design. The torque transfer flows differently. So this is actually like a 3844 helix, which is it's a different range of numbers than you'd expect with the other clutch. But again, the torque flows through it differently. So we need a different type of a ramp angle to get the desired amount of clamp.
Yes, sir.
Our springs have a proprietary process that we've worked on to improve their ability to maintain their loads over time and through heat cycles. I know with past springs, we've had them where 5,000 miles or 500 miles, 1,000 miles, if they're running high heat environments, they'll start to lose their loads. We've improved that significantly with these springs, and I should say that that's also been improved with Turbo S and RS1. If customers have paid much attention to those also have those processes.
Yeah. Well, thank you very much. I really appreciate you showing us all the improvements. You guys did your homework once again, and look forward to seeing these things out on the trail.
Yeah,
Thanks very much.